Hello everyone, I'm back with our fifth lesson of Math Fundamentals talking about 2D and 3D geometry shapes. We're going to learn how to understand, how to apply today. Enjoy. So in today's lesson, we're going to first learn about what are 2D and 3D shapes. Secondly, what are some key things to understand. Thirdly, we are going to find how to find the area of trapezoid, area of polygon, and some problem solving in the end. So what are 2D and 3D shapes? A two-dimensional object is an object that only has two dimensions, such as length and width. A three-dimensional shape is an object with three dimensions, a length, a width, a height. In short, 2D shapes are shapes that can be drawn on flat surface, while 3D shapes are solid shapes. I'll help you draw here to help you understand better. 2D shapes are something like this. Or they are flat shapes. We cannot see them in different angles, but we can only see it from our perspective. That's why it's called 2D. While 3D shapes are something more like this. Now, what's the main difference between 2D and 3D shape is that 2D you only can see it in our eyes that way on one way. But 3D you can see from this front side or the side or the top. We can see it in a various different angles. That's why it's called 3D shapes, and that's their main difference. There are some key things to understand in doing 2D and 3D shapes. The type of questions that will be discussed about 2D and 3D shapes are very limited in MYP2. This is due to the fact that MYP2 is still the basics learnings and the fundamentals. There are only three types of question, whether it asks the area, the surface area, or the volume. Understanding each concept will be essential and key in getting high grades. Now I want to show what area for you guys to recall and review the things. Area is how much this rectangle is covering. Now we can do that by multiplying the L length with the width. Now to find the surface area, we should add the area of every single surface. Adding the area of every single surface. So let's think of a cuboid. In a cuboid or a rectangular or something, a shape in front of us like this, there are 6 sides. 6 sides. And adding the area of each side will end up in the surface area. The reason for this is because surface itself means the outer part. So adding all the outer part is same with adding all the shapes that's forming the 3D shape. Therefore, you should add 6 sides, which could be 4 times 6 plus 8 times 6. So this is 8 times 6. This is 4 times 6. And on the top, that's 8 times 4 plus 8 times 4. So 24 plus 48 plus 32. But those are only three sides. There is an exact same sides on the opposite. So we should multiply 2 here, which ends up with 780 plus 24, 124 times 2 equaling 248. Just like that. Now, the most discussed other thing is the volume. To find the volume, we should find the area of base. After finding the area of base, you should times the height. The reason for this is because let's try to draw our cuboid here. The volume means how much you can contain inside of it. If this is 8, if this is 6, 6, and 6, it would be 6 times 6 being 36, and this layer being 6 centimeter times 6, 216. Just like that, we can find the volume. Let's try with the rectangle next to us. 8 times 4, which is the base, multiplied by 6, which is the height, resulting in 36 times 6 equals 192. Simple as that. Now, another new shape that we start to learn is the area of trapezoid. The formula in finding the area of trapezoid is b1 plus b2 times height times 1 over 2. The formula is very complex, and this only can be proven when you go step up in IB learnings. Currently, it is very hard to explain how does this formula actually work. But as we learn through the math, we will find out, oh, that's why this formula works. But just for now, right now, let's just use the formula. So a trapezoid has 3 different shapes. Number 1 is this. Number 2 is this. And lastly, number 3 is this. The first one, which has right angle. Second one, which has right angle on this side. And third one, let me redraw it. Like this. Like this. Something irregular. But all their formula for finding all their areas are same. The top part is called B1. The bottom part is called B2, representing base 1 and base 2. This part is called the height. To find the area, we should add B1 plus B2 multiplied by the height times 1 over 2. Let's try to apply that in our learning. The question next to us shows like this. Okay. A trapezoid with 5 on the first, 9 on the second, and 3 on the side. So we add 5 plus 9, which is 14, times 3 times 1 over 2. 14 times 3 times 1 over 2. 42 times 1 over 2, which equals 21 centimeter square, because it's finding the area. Let's try number 2. It's the same question. Like this. 6, 10, with a height of 7. You add 6 plus 10, multiply by 7, times 1 over 2. This equals 16 times 7 equals 1 over 2. And that equals 112 times 1 over 2, which equals to 56 centimeter square. Now let's go to the area of polygon. In the area of polygon, so there are a lot of polygons, but the most polygons that you're gonna see is this types of polygons, which has multiple sides: pentagon, hexagon, octagon, and more. And when you're finding the area of this kind of polygon, which has more than multiple sides, more than 3 or 4, we need to find it by creating a triangle here. Like this. Forming a triangle. 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 This is homework for you guys, and I'll solve this A question. Now, to find the area of a polygon, you should create multiple triangles. So we know that the sides, the length of the sides are 30 centimeters because it was already given, and all these sides has the same length, and the height here is 26. 30 times. What should we do is we do 30 times 26 times 6 times 1 over 2. So what's happening here is that we're trying to find the area of one triangle, because this 3, 4, 5, 6 triangles all are equal. All of them are same triangles. They have the same area. They have the same side. They have the same height. They are all equal triangles. So let's just find one of them and then multiply by 6. To find the area of triangle, we should do 30 times 16 as its height times the base times 1 over 2. And that's how we found this. So now let's do it. Hand manual calculation. 30 times 26, 0, 18, 0, 6, 0, 8, 780. We found it. So 780 times 1 over 2 times 6. 390. So this is one triangle times 6 pieces. So it's going to be 390 times 6 equaling 0, 54, 18 plus 5, 23. So equals 2,340 meter, because the question is meter. It's 40 meter square. Now lastly, the problem solving. A Stonehenge in England is one of the most mysterious human landscape ever constructed. Nobody exactly is sure how the stones, some of which weighed as much as 20 metric tons, were moved. An outside circle of the sarsen stone surrounds a smaller horseshoe of bluestones, with the structure seeming to point in the direction of the sunrise during the summer solstice. The stones are arranged in a circle with a diameter of 33 meters. There's a clue, 33 meters. Important. A diameter of 33 meters. It is believed that the Stonehenge was built on a sacred ground, that among other things, it was a burial site. Despite many theories, scientists are still trying to unravel the mystery of Stonehenge. The certain stone in the outer circle can be modeled by the rectangular prism, with a base of 2.1 meters and 1.1 meters and 4.1 meters in height. It is thought that there were 30 such stones in the outer circle. So what is the area of the Stonehenge cover? So let's try to draw them. So there is a circular thing. There's a lot of stones around it. But we found that the diameter is 33 meters, and it was stated. We should state all the measurements. And then, to find the total area of the stone jet, how much area that the Stonehenge covered, we should find the area of the circle. The area of the circle, as we have learned in the elementary, is pi times r squared. R is radius, is 2r equals diameter. So r equals diameter divided by 2. Since the diameter is 33 divided by 2 equals 16.5. So the radius is 16.5. We have found that. And we should square that value and times pi into it. So it would be 16.5 square pi meter square. Just like that. Now, find the total volume and the surface area of the 30 sarsen stones. So one stone can be modeled by 2.1 meter. So there is a stone like this, a rectangular stone, rectangular prism, with a 2.1 meter, 1.1 meter, and the height of 4.1 meter. And there's times 30 stones. To find the surface area, we should do 4.1 times 1.1 plus 2.1 times 4.1 plus 2.1 times 1.1. The reason is because this part is this 4.1 times 1.1, while this part is this, while lastly this part is this. And since there are one more side that's exactly the same, we should multiply by 2 in the outside. So we just do that. 4.1 times 1.1 is 4.51 plus 2.1 times 4.1 equals 4.61. And lastly, 2.1 times 1.1 equals 2.31. We plus all that equals 15.43. So now 15.43 times 2 equals 30.86. Now, one sarsen stone has a surface area of 30.86 centimeter. Since there's 30 sarsen stone equals 30.86 times 30, which equals to 925.8. That's it, centimeter. Now, for the volume, it's your job, guys. It is your time to show what you have learned and show me. Thanks for today's lesson. Until here, and see you next time. Bye.